September 12, 2025. Sky watchers witness the unthinkable. A massive entity hurtling from the void of space. Its luminous trail spans 5 full moon widths, eclipsing every celestial visitor since Oumuamua's passage. Hours later, confirmation arrives. A second intruder approaches, both charging toward our star in synchronized flybys separated by mere days, yet emerging from opposing regions of space. Mathematical probability labels this dual appearance as virtually impossible. The conventional explanation: paired comets. Yet the data suggests something far more deliberate. A mysterious construct penetrating our solar neighborhood with unknown intentions. Random cosmic event, or the opening gambit of a calculated intervention we somehow triggered? The truth begins here. September 12th brought a discovery that froze astronomical teams worldwide. The SH mission SWAN detector captured an anomaly blazing through our planetary system. First measurements revealed a tail extending nearly 2.5 degrees, roughly 5 times a full moon's apparent size. Such dimensions are unprecedented for newly identified comets. Photometric readings registered magnitude 7.4, placing it within range of modest telescopes and quality binoculars. Word traveled rapidly through observation networks as amateur stargazers rushed to verify the satellite's findings. Australia's observers, just 48 hours post-alert, documented a spectacular light streak threatening to overflow their imaging equipment. By September 13th, the International Astronomical Union formalized the designation C/2025 R2 SW, crediting the discovering instrument. Professional and amateur communities united within days, exchanging imagery and luminosity data across continents. The unprecedented scale and brilliance triggered immediate speculation. Modern comet discoveries typically yield dim objects requiring advanced equipment for detection. SW defied this pattern, visible to anyone with basic knowledge of its location. Its magnificent tail carved through Virgo's constellation, intensifying as solar distance decreased. Initial responses mixed wonder with skepticism. This transcended typical icy wanderers from the outer system's depths. The measurements challenged recent precedent. Evidence accumulated confirming SW's dramatic solar system presence, unseen since Hale-Bopp's era or earlier. Amateur communities, traditionally first to detect brightness variations or unusual behavior, immediately debated the mechanisms driving such extensive, brilliant tail formation. The object proved simply too large, vivid, and rapid to dismiss. As global telescopes tracked its trajectory, focus shifted from identification to timing, and whether its arrival marked the beginning of a far stranger puzzle. C/2025 R2 SW wasn't the only remarkable newcomer demanding October attention. Days before its detection, another entity, 3I/Atlas, was already approaching from an entirely separate sky sector. SW's trajectory traces through Aquarius, while Atlas originated from Sagittarius direction. Celestially mapped, these arrival vectors span over a quarter of the sky sphere. Yet both objects target solar perihelion within an identical 10-day period. SW reaches closest solar approach around October 20th at approximately 150 million kilometers. Atlas achieves perihelion October 17th, merely 3 days prior, passing roughly 203 million kilometers from our star. This positions their closest points only 50 million kilometers apart, nearer than Mars-Earth minimum distance. Beyond overlapping schedules, the orbital geometry proves remarkable. Both follow severely inclined paths. SW tilted 60+ degrees from the ecliptic plane, Atlas nearly perpendicular to planetary orbits. Their approach angles differ so dramatically that coincidental timing for both crossing inner solar system regions simultaneously at comparable solar distances becomes statistically negligible. Long-period comet and interstellar object specialists expect random arrivals scattered throughout calendar years, with perihelia distributed across months or seasons. Instead, this decade's two brightest new discoveries converge on solar approach in near-perfect synchronization, each from opposite sky quadrants. Timing complexity deepens further. As both SW and Atlas execute closest solar passes, Earth's observational capabilities face effective blindness. October 8th through 18th, solar glare blocks direct observation, creating a blackout spanning critical days when unusual behaviors would be most detectable. Peak proximity moments, to both sun and each other, occur beyond ground-based observer reach, preventing real-time event monitoring. Two objects from vastly separated origins achieving perihelion within days, at nearly identical solar distances, during periods when solar interference shields them from view. This defies standard probability expectations. Orbital mechanics terminology labels this a corridor, a precise spacetime window both objects occupy simultaneously. Whether representing coincidence, hidden connection, or engineered design remains uncertain, but the geometry alone gives pause to even the most cautious astronomers. 3I/Atlas initially attracted attention not for brightness, but for rule-breaking characteristics. Early Atlas Spec Lab Group spectroscopic analysis reported alarming findings. A body dominated by nickel with virtually absent iron content. This contradicts established comet knowledge, as such objects typically display iron-nickel combinations in their vapor signatures. The unexpected claim prompted immediate data verification requests, sparking calibration debates across astronomy forums and triggering multiple independent reviews. Controversy intensified with subsequent measurements. Rather than classic water vapor signatures, 3I/Atlas's coma expelled carbon dioxide at 5 times the water rate. The 4.3 micron CO2 spectral line dominated every reading, while H2O barely exceeded background noise. Though unusual, this isn't unprecedented in cold origin comets. What defied easy explanation was tail behavior patterns. Atlas tracking revealed a specific sequence, 3 distinct acceleration phases, each separated by roughly 2-week intervals, each corresponding to sharp tail color transitions. Initial pulse occurred July 29th, followed by August 14th. Photometric data showed sudden brightness jumps while spectral slopes shifted from reddish to neutral, then returned. These delta 5 pulses weren't gradual solar heating responses. They activated rapidly, then diminished as if the object had fired propulsion systems. Peer reviewers challenged these findings, citing calibration drift risks or systematic errors. However, Atlas Spec Lab teams defended their results, noting pulse timing and magnitude consistency across independent observatories, from Aberratracker networks to Bill Gray's distributed telescope arrays. The numerical behavior differed from typical outgassing patterns. The tail CO2 composition seemed synchronized with each acceleration, a phenomenon termed thrust mix modulation. Energy estimates truly ignited speculation. If observed accelerations proved genuine, the implied internal power source would require approximately 10 gigawatts, equivalent to 10 large nuclear facilities. This far exceeds any known comet nucleus capabilities. Mainstream perspectives still attribute most data to natural processes, but gaps, particularly the nickel-only spectrum and stepwise accelerations, sustain the engineered object hypothesis. The Atlas anomaly file remains active, with each dataset fueling both skepticism and speculation. C/2025 R2 SW occupies a unique category. The statistics tell the story. A 2.5-degree tail, brightness peaks rivaling the century's finest comets, and a core that, if extreme estimates approach accuracy, could generate 10,000 gigawatts. This exceeds Earth's entire power grid output significantly. Scale isn't the only discussion point. Claims from astronomical community fringes suggest SW possesses armor, shielding, and power systems stretching current physics limits. Initial rumors stemmed from reflectance data. Standard comet nuclei scatter sunlight predictably, but SW's core reflects light with distinct metallic characteristics. Amateur spectroscopists argue this matches not just nickel, but nickel-cobalt alloys, materials selected on Earth for strength and corrosion resistance. The term nickel-cobalt hull circulated through chat rooms and late-night podcasts, fueled by the object's stubborn resistance to fragmentation or dimming during solar approach. Reports followed of optical anomalies, persistent silvery halos surrounding the nucleus, shifting in pattern and intensity. Some interpreted this as plasma envelopes, electromagnetic shields capable of deflecting solar wind and cosmic debris. Hence the fortress designation. Unlike 3I/Atlas, which behaves more like reconnaissance, quick, agile, oddly efficient, SW presents as a battle wagon, slow, steady, seemingly invulnerable. The record-breaking tail pulses with microthrusts defying simple outgassing models. Photometric analysis reveals tiny rhythmic tail direction changes, suggesting precise plasma burst course corrections. Each pulse registers as brightness curve fluctuations, repeating with regularity difficult to attribute to random surface eruptions. Orbital calculations add complexity. SW follows a path requiring 22,554 years per solar circuit, a cycle spanning back to the last ice age. The implication stunts. If this object represents engineering, it's maintained a predetermined course longer than human civilization's existence. Yet it arrives now, simultaneously with Atlas, in the same solar corridor, during Earth's telescopic blindness window. All these factors combining by chance approaches statistical impossibility. This feeds growing conviction that SW transcends typical comets. Its sheer luminosity, advanced shielding hints, possible armored construction, and massive energy output make it the most formidable inner solar system visitor in living memory. Whether fortress, probe, or something else entirely, SW has forced astronomical rule rewrites and opened theoretical doors previously reserved for science fiction. Every major anomaly recorded for SW and 3I/Atlas has shifted discussion from object identification to potential activities. When two massive bodies, one on a 22,554-year return cycle, another on hyperbolic, possibly interstellar trajectory, arrive nearly together, pure chance probability collapses. Timing, geometry, and blackout windows have spawned numerous mission theories. One possibility appears almost routine by cosmic standards, scheduled maintenance or refueling operations. This scenario positions the Sun as a service stop. Both objects could be engineered for solar energy or magnetic field utilization for recharging, data transfer, or systems diagnostics. The concept isn't far-fetched in deep space mission planning. Earth employs solar flybys routinely for gravitational assists and energy boosts. If these represent probes, the Sun becomes the logical power and information exchange point. Another theory suggests less peaceful intentions. The close approach could constitute intervention, a rendezvous to recover or neutralize malfunctioning units, or perhaps competition between rival factions converging on resources. Power levels estimated for each object. Atlas around 10 gigawatts, SW an astounding 10,000, indicate energy reserves necessary for active maneuvering beyond passive drifting. Stepwise accelerations and tail modulations in Atlas, plus micro-thrust pulses in SW, suggest control levels consistent with mission profiles rather than random outgassing. The audit chain scenario presents another framework. Oumuamua in 2017, followed by Atlas and now SW, could represent escalating responses to Earth's century of radio transmissions. Each arrival would constitute increasingly complex probes dispatched to investigate, gather intelligence, or escalate contact protocols. Across all frameworks, the Sun isn't merely background. It's the power node, rendezvous point, and beacon. Evidence doesn't resolve debates, but forces new questions. If this represents a mission, what's the mission's purpose? A 22,554-year orbit transcends mere numerical data. It's a cycle reaching deep into the last ice age, when Earth bore no resemblance to today's world. Around 20,000 BCE, glaciers covered northern hemisphere expanses, and climate shifted in ways shaping human civilization's earliest chapters. This epoch left traces in Greenland and Antarctic ice cores, where dust layers and minute chemical variations hint at sudden dramatic sky events. Some researchers note these layers align with periods when bright long-period comets could have passed, leaving not just debris, but stories echoing through generations. Central to this concept stands Göbekli Tepe, southeastern Turkey's site constructed over 11,000 years ago. Its stone pillars display animal and abstract symbol carvings, including motifs some believe represent sky object paths, possibly comets. A few theorists argue these carvings document cycles exceeding human lifespans, potentially marking returns of SW-like objects. Mainstream perspectives remain cautious. Archaeologists and astronomers warn these connections are highly speculative, built on patterns potentially attributable to chance. The debate intensifies, with critics noting no direct evidence links ancient monuments to specific astronomical cycles. Still, timing proves difficult to ignore. If SW truly returns every 22,554 years, its last inner solar system passage would have occurred as the world emerged from glacial grip, precisely when human culture began monument construction and celestial tracking. Whether coincidence or something more remains uncertain, but it adds mythic resonance to an already extraordinary event. SW's story transcends numbers and orbits. It's about the possibility that the sky's rarest visitors have always been woven into our own beginnings narrative. October 8th through 18th presents a hard stop for every major ground-based observatory. Official schedules list this window as solar conjunction downtime, but restrictions extend further behind scenes. Internal communications from U.S. Space Command and the European Space Agency direct teams to suspend all radar and high-resolution imaging of both SW and 3I/Atlas during this blackout. Alternative coverage proposals face unexplained denials. Raw data requests receive quiet rerouting or delays. Telescope allocation reviewers, speaking confidentially, describe explicit orders avoiding public statements about either object until post-perihelion. The result creates enforced silence at the precise moment when the two most unusual decades-long visitors cross solar glare, leaving only narrow bands of independent astronomers and amateur networks to bridge the information gap. When blackout orders activated, official channels fell silent, but amateur networks persisted. Bill Gray, a veteran tracker renowned for open-source orbit calculations, began mobilizing a distributed web of backyard astronomers and small observatories. His call spread across public forums and encrypted chat rooms. Maintain sky observations, document every fluctuation, and share raw data before it vanishes. Spain and Portugal's Abro Tracker Collective started pooling wide-field sensor feeds, while Private Astronomy Group leaks suggested improvised plans to circumvent blackouts using radio telescopes and repurposed weather satellites. With government agencies off-record and major observatories locked down, grassroots efforts became the sole defense against complete information vacuum. Anyone possessing telescopes, radio dishes, or access to open-source tracking software could participate. The blackout window wasn't just a challenge, it was an invitation. If answers are desired, you're now part of the investigation. When SW and Atlas re-emerge, initial signals might originate from someone's backyard, not government laboratories. The evidence stands clear. Two anomalous objects entered the inner solar system together, defying statistical probability and raising questions no agency has addressed.